Hello guys, good day. So we have A200840, which is a 2017 motherboard. Now we have power issue on the system. The customer said no power on the system. So when it came to the office, we have 19 volts present, but the amperage is 0.008 or 0.009. That's the variation. So what we're going to do now is to check for possible shorts on any of the coil. From the coil, you can know if you are having shorts on the system also, because each coil represents all the switch line on the motherboard. You remember you have 3 volts, 5 volts, 1 volt, 0.9 and the rest. So now we are checking for possible shorts on all the lines, and it seems that where we are facing the short is mainly on 3 volt switch line. So to be very sure on this, we have to use our fastest method to check for the short. Now we're going to use our flare camera to inject voltage on that particular line. So when it's been injected, you can see from the flare camera display that there's hotness on that area. So now the hotness is on the area, simply means that the error is coming from there. So we are going to check for the short around that area, and we are going to pull out the bad caps that's possibly causing the shorts, possibly causing the system not to come up. So the 3 caps present there are suspect. So the option you have is to pull out the 3, and once you pull out the 3, you can now read from the 3 capacitors to know the exact one that is bad. So we are going to now power on our hot gun or our workstation to apply more heat so as to soften the lead and pull the chip out. So we have applied paste. The reason for the paste is to make the surface or the environment where you are applying the hot gun to be soft so as to easily pull out. So actually this takes us a lot of time before we could be able to pull it out, because when there is shorts, there is a tendency of hardness of chip to the board. So it must apply a lot of heat and a lot of oil to help soften the surface of the terminals. So you can see here we are trying to pull out the 3 capacitors. We are doing our best, though it's not easy, so as not to affect the other terminals or the other areas. So we are going to pull it out. We are working higher. We've increased. This is very strong, very, very strong, but we'll still continue trying. You can imagine how strong this capacitor is. You can imagine how strong it is. Okay, let's keep pushing. We've now add more oil paste. Okay, so we will now pull it out. Now we've already pulled it out. Now you can see here finally we succeeded in pulling it out. So we are going to test to know the bad cap that is faulty. Now testing the bad cap that is faulty, remember it's 3 caps, so 1 will be the cause. One of the cap is going to be the cause of this issue. So we've got to identify the one. So now it's time to replace, fix in the ones that are good, and now replace the one that is bad. So we're now applying our oil paste again, so as to make our environment smooth for easy contacts. Okay, so we'll now put the first cap. You can see how easy it's going to be going in because we have softened the environment. The layers on the terminal is now softened. It's now easy to penetrate because before, because of the short that the system is having, automatically the layers terminals are very hardened. The oil that is being used to make it easy for removal and to fix back has been dried up, so it's going to be very strong, and because of that you apply much heat so as to make it easy. Now we are going to put in the third one, which is the one we replaced, which is the bad one that we'll replace. So we'll fix it in now and apply more oil paste also to soften the environment also. So we're going to fix it in. Okay, so the third one has been replaced now. So what next? Next is to check if we still have 0.08 on the amperage line. Remember, we are having 0.08 on the amperage line, so let's test now. So you can see here we don't have 0.08 on the amperage line. What we are now having is 0.54, 0.6,